All right, let's get this thing started. Hello, everyone. Thanks for choosing to spend the next hour with us for our webinar, Let's Shift Left. Sure, but how? My name is Kristen. I see some repeat attendees, so you guys know us very well. I'm the head of marketing here at 42 Crunch, and today I'm joined by our queen bee, Isabel Mani, who'll be doing all the heavy lifting for this presentation. So before we get started, the usual housekeeping that is probably so repetitive to some of you, sorry. You guys will be muted through the presentation, so there's no disruption. If you have any questions, please enter them into the Q&A and not the chat. I'll go to the Q&A first. We will address the questions at the end of the presentation. And any questions we don't get to, don't worry. We do a follow-up blog after every webinar that has the answers to all the questions in it. And I've already got a few questions about this being recorded. Yes, it'll be recorded. We record every webinar, and we'll send out a link to the webinar when it's published, along with a link to the Q&A and any associated materials like the slide deck or data sheets. So you guys will get that. If you have any unrelated questions to the webinar or are having technical problems, put those in the chat and I'll do whatever I can to help you. Now let's get started. While you're really here, I will let Isabel take over. Cheers, guys. Enjoy.
Thank you very much, Kristen. So welcome everyone, newcomers and faithful followers of our webinar series. So I'm Isabel. I'm gonna spend the next hour with you here, 15 minutes, talking about shifting left and DevSecOps. The reason we are presenting this today is we're really working with a lot of customers who are putting this in place more, at different levels of maturity, I would say. And we thought it would be a good opportunity for everyone to understand what are others doing, what are they envisioning, their best practices, and share that with all of you. But before we actually do that, I just wanted to spend a few minutes to explain what are the challenges around security in general, and one of the key reasons automation is probably a good idea to actually follow. The first one, and we see that a lot, is okay. So we have APIs. They're being developed by the development people, and at some point in time, we need to test them and see if they are secured. So when is this happening? Well, it is happening in many places. It is not happening in some places. And in many places, it's like, oh, let's do that later, right? So now we really have to focus on the business implementation, on the functionality. What really matters is that the API does what it should do, that we can satisfy the business requirements and what the application should do. And some kind of security kind of gets in the way of that, in a sense. So depending on the processes which are in place, so we tend to forget about them until kind of the last minute, and maybe we just don't test things the way we really should have tested them, simply because we wait too late, and then it becomes too much of a problem, right? So that's the first kind of major trend that we seem to see. The second one is, what do you mean we're deploying an API again? Which is like, we used to deploy things like every month or every 2 months or 3 months, and now we're deploying even every day. And so the benefits of automation on the development side. So you click on a button, the code goes into some kind of pipeline, it's being validated automatically, getting deployed automatically, and I can test it right away. So this agility that we have gained on the development side means that we're super productive from a development perspective, but we're left a bit security behind. We have not given them that same agility for them to follow that same rhythm, right? So the speed at which we're actually changing the APIs, plus the sheer number of APIs. So There's like a lot of numbers flying around, 200, 300, 500, which are like the average number of APIs in an enterprise. The key thing is, in all the customers and enterprises we work with, it is definitely in the hundreds and not in the dozens, right? So as you go and change those and they evolved individually, then keeping up on that development as a security person becomes more and more and more challenging. So that's the second aspect. And the third one is, we tend to neglect that a bit, is like, this is not simple, right? So if you can read that phrase and understand what it means, fantastic. You're probably part of the 10% of the population can actually understand that and thoroughly explain how it works and why we're doing it. The other 90% or 80% maybe, it's complicated to understand what has to be done to secure APIs, for example, at authorization level, at authentication level. There's a lot of things to put in place to ensure we're actually doing this. Like, this is my role, and I want to do that across all my APIs. How do I make sure this is actually happening? How do I make sure somebody is not putting basic auth instead of that, top-notch security that I want to put on my APIs? So I need two things here. I need to make sure that whatever I have enforced is what is actually applied. And then I have to put in place the right tools so that those complicated concepts can be kind of abstracted, if you want, to the developers or whoever has to put them in place, and make it much easier to apply this automatically, again, across my 100, 200, 300 APIs, which is really, again, the core problem. So that's kind of our core three problems. We have a scalability problem, we have a skills problem, we have a speed problem, and how do we fix that, right? So this is where we need a new approach, right? And what is this new approach? The new approach is really, as you probably understood, to give really the means to the security to become as agile as the rest of the company. We have automated development, we have automated operations, we really have an automated security across that life cycle. And this is all really about making sure that the security can keep up at that same rhythm. And also making sure that all the different roles which are involved in doing security actually talk the same language. And one of the key problems has been so far, like if we do Kubernetes, we have infrastructure as code. We can describe now our architecture, our infrastructure. We can automate that. We can put the description of our infrastructure in a GitHub repository, and we can compare what was the previous deployment versus the current deployment, who has done it, what has been changed, etc., etc. We don't have that in security at the same level of maturity today. Very few people have the ability to say, oh, this is my security described as code, and I know exactly what has been applied here. We're getting there, but it's not as mature as it should be. And that's really where we want to be. We want to be, on security at the same level we are on code for development, which is there for a long time, but also from an infrastructure point of view. And what does that mean, really, right? The idea is we want to really get started with security much earlier in the development cycle than we are today. So today we tend to worry about security at deployment time, right? So the idea is like we want to start worrying, injecting security much earlier. And if it can be done at design time, even better, right? Testing is already, the good improvement. Development is even better improvement. Design is like probably the best, right? But it's going to take time to do all this. But that's kind of what we want to get to, right? And one of the key reasons we want to do this, and this applies to security the same way it applies to any defect. In the end, a vulnerability in your code, in your APIs, is just, it's a bug, right? It's a bug that you have to fix. So it's a bug that you want to discover as early as possible, so that the cost to fix that bug is as low as possible, right? So we're going to make an investment in shifting left and discovering those issues as early as possible. That's going to have a cost, right? But that cost will be outweighed by the fact that the cost of the fix is actually much lower, okay? Now, how do we do this and what do we have to do? So the first thing that is really critical to understand, and this is really the same for DevOps and then SecDevOps, right, is that first and foremost, this is a change of culture. It's not, so yes, there are tools and we're going to talk about those, but this is really about collaboration and working together as different groups. And it's a change of the way we're doing things. So it's not enough to just say, oh, I'm going to buy some tools and we're going to continue to work the same way we were working before, where development, operation, and security are operating in a completely isolated way. That is not going to work, right? You really have to change the way you're working. You may probably have to restructure your development teams to be, mixing development, operation, and security together. So it's all about collaboration, really. And if this is the first thing you really need to embrace if you want to do DevOps or DevSecOps. And the second thing is really what we're going to do here is to establish some processes. We're going to establish how we work in a repeatable way, so that we know, okay, this is what we have to do when we deploy an API in dev, in QA, in production. We have well-established processes of things that have to happen from a security standpoint, and everybody is kind of following those processes. So that's really, we have to establish what those processes are. And last but not least, we have to equip people with the right tools, right? So one of the key aspects of DevSecOps, and we've seen people failing doing that because they said, okay, well, if DevSecOps is about development starting on security, let's get the development guys to use security tools. That doesn't work, right? The security tools are made for security people. Security tools you may have that have been created 10, 15 years ago, and that don't have that philosophy in mind, are not going to work for development today. You really have to shift those tools to look at things that are adapted to the developer flow. We're going to talk about this in a minute, but that's a very important aspect of things, just to make sure you're giving the right tools to the right people for the job that they have to do. So the benefit that we're looking for really is, rather than saying security is the problem of the security people, right? We say no, security is a problem from along the path of developing the API, and everybody has a role to play. The developers has a role to play. There's obviously security has a role to play, and operation has a role to play. So again, it's about changing the way we work together, right? What is it going to give you? It will give you security by design. Everything is automated, the testing, the reviews, geared towards security. It will make security transparent. So it's not like this black box of people working on the side and doing this fancy pen testing and things on that. That's not what we want. What we want is really a process that is transparent to everyone, where the same way, again, I have my infrastructure in Kubernetes in GitHub, I want to have my security described in GitHub. So everybody is aware of how security is done, and it's completely a transparent process, and it's very easy to follow and understand. What we also want is getting the development community, which traditionally has been kind of isolated from this. We're more, in many places where we go, we're more in a spirit where I'm a developer, my job is to do the code, and then I'll push the code somewhere and somebody is going to go and review it, right? So the problem with that approach is, one, it doesn't scale again, and the second is you keep repeating the same problems again and again. But you find the same problems again and again because you don't have that feedback loop, which is a very critical aspect of DevSecOps, is to feedback saying, hey guys, when you do this, that's a problem, right? And then we're going to find this type of issues when we test it. So please don't, take a different approach when you do the code, so that we eliminate at the root that problem and we don't see them across all our APIs. So it is important to have that feedback loop that will help developers better understand what are the best practices, what are the consequences of certain practices in the code, so they learn from this and don't do it again, right? I go to a lot of conferences, well, I used to go, there's not many conferences happening this year, I think. I used to go to quite a lot of developer conferences and talking about security to developers. And what I tell you is like, of course, I don't want to, I don't want to inject some security problems in my code. That's, of course, I don't want to. But what I need is to learn why what am I doing is a problem. And that's really the information that I'm missing, right? So back to that feedback loop, that's critical. And what this will allow us to do is to continuously improve the security. This is not a big bang thing. You're not going to go from I have zero control and zero self DevOps to like 100% automation from day one to the next. That's not going to happen. But what you will do is start and improve through that feedback loop, getting better at it to the point that it becomes a habit for everyone to work in this new way. And it will doesn't become a problem anymore. It becomes something which is simply part of everyday's life of a developer and everybody working around the code. So that's really where we want to get. Now, what do we have to do? So I borrowed this picture from a blog that you can see the reference at the bottom from a gentleman. This was written by a gentleman called Jeff Williams. Jeff is one of the key authors of the OWASP top 10, of the original OWASP top 10. And this is a really good way of saying what is it that I have to do to do DevSecOps, right? So we're gonna go around those 4 different steps: analyze, defend, and secure and verify, right? So that you understand better what it is that we have to do at each of those steps. So the first step is analyze. So just to make sure you understand this is really about what is it that I have to secure. So you cannot secure what you don't know, right? So the first step is to understand what it is that you have. So that is really important. You really need to know your APIs and the risk attached to those APIs, right? This is all about threats modeling. And in the world of security, everything is about risk, right? It's all about what is it that I have to do for that type of APIs of mine versus this type of API of mine. So if I give you an image around this, right? If I have to close a house, there's a common way of doing it, which is to have a door. Okay, a door can have a very simple lock, right? Or it can have like this super highly, sophisticated lock. It can have like, I don't know, facial recognition or anything like this, right? You're not going to put a door with facial recognition and a super expensive security system, most likely on your home, right? Now, you probably want to do that at the entrance of your data center, right? Because the risk is very different, right? So you need to understand your API. So there's a lot of customers asking us about API discovery, because unfortunately for people, when you have a large enterprise, it is very easy to create new APIs now for developers. They kind of pop up, all over the place, and it's hard to keep up on how many APIs do I have. And you're surprised by when you ask that question to people, they're like, well, we think we have X, right? And they'll go and search and say, oh, actually, we had 500 more because we had all those things that we didn't count and everything. So you really, really need to know, what are my APIs? What do they do? What kind of data they're accessing? Is it sensitive? Is it PII? Who is going to access that data? Is it partners? Is it, Jodo anywhere in the world? Is it, you need to have that picture of the enterprise aspect of your APIs, right? You need to have that overall picture. Inventory was the word I was looking for, sorry. The overall inventory of your API, so that you can really apply and take decision from that then, right? So the whole discovery process is really important, and it's key to anything else. And again, the risk is the key thing. So now, once you know that, right? Once you know what you have, then comes, okay, what do I want to do? It is based on the risk, based on what I have, how I use APIs, who I am, etc. What are my rules? What are the rules I want to apply across the board on my APIs within my enterprise? For example, we want to make sure that every single API we want to enforce across the board, enforce, and know where it's done. So this is very important. Working with a lot of customers right now, where people tell me, yeah, of course we're doing validation across, against JSON schemas. Well, of course we do. So okay, where do you do it? Well, we do it, right? But then when you're being asked to point to where for sure 100% it's actually done, then the response become more like vague. Is it done in my API gateway? Is it done in my code? Is it done in both? Or is it not done at all? You have to know, because this is critical. 80% of attacks come from things which are not validated. It's input and output validation. So where is this validation done, by what, and is it really 100% complete? Do you really do that? Same thing for tokens. You don't trust tokens. How do we validate those tokens? Where is that done? Again, like things like I have a JSON web token in place for security. Is it signed with the right algorithm? Does it contain the proper claims that I'm expecting? Does it have the issuer that I'm actually expecting? Does it have the audience I'm actually expecting? All of these things you need to validate before you even consume that token. That's very critical. Is authentication in place everywhere? If yes, how? Is authorization in place everywhere? And yes, how? How is rate limiting enforced on all my APIs? Is it in there? Where is it done? Is it business rate limiting? Is it technical rate limiting? There's a lot of different rate limiting and throttling ways here. How do I manage my data? So my secrets, I'm sorry. Am I sure that there are no hard-coded keys anywhere in my code? I didn't put that in my mobile application, for example, or in GitHub, or in deployment scripts. I have zero risk to leak those keys one way or another. Do I use security headers? Am I sure to know at any point in time, all those libraries I'm importing from NPM, from Maven, from wherever it is, which ones have vulnerabilities, and what should I do to actually get rid of that? Make sure that everything is logged so I can have forensics on security. So all of these are just examples, right? Your journey will vary depending, again, on the risk and what you have to do. This kind of the top 10, I would say, of the things that usually you have to do across the board independently from who you are. You may also have some governance and compliance requirements that add on top of that list, right? So there is another, we have this OWASP top 10 for APIs now. There's a very good how to prevent section in each of those. Look at how to prevent and make sure you put all of that in place, right? So those are my rules. That's the things I want to do, okay? Now, once I have decided what I want to do, now I have to make sure I'm actually doing it. And this is where the automation comes in place, really. Because this is where you're gonna, this is where you cannot do things manually anymore, right? I was talking to a lady recently on a call for for a demo, and she was telling me we have like 2,500 APIs, right? And out of those 2,500 APIs, I know I'm probably testing 1,000 regularly from an app spec point of view, and the rest, that's why we want to put automation in place, because I'm pretty sure there's some with that sheer number of APIs that are escaping AppSec on a regular basis, right? So how do we prevent that from happening? Well, the only way is to automate everything at different stages. So first thing, it's kind of a busy chart, but bear with me here for a second. We're in dev mode, right? So in dev mode, what do we have to do? In dev mode, really, this is where you're going to find tools that do code analysis. API contract analysis is what we do, for example, right? Audit your API contract to make sure that you have the proper definitions of schemas in there, back to my JSON schemas. And code analysis and SCA, software component analysis. This is all the part about automating and making sure that the libraries I'm using don't have existing CVEs, and you have all kind of tools that actually allow you to do that, right? Those are just sample tools. You have to go and investigate the ones that you want to use, right? But already, if we do all of that at dev time, we want to automatically eliminate all the basic problems that would be there and don't want to leave them. And we don't want to discover those basic problems, those things we can discover through those tools when we are going to deploy and test and start testing or deploying our APIs. We want to do that earlier. So that's the first thing. And QA and testing. So this is repetitive things. So every time, sorry, back to dev, back to dev, what we want to do here is every time you push some new code in your whatever, in your GitHub, in your Git, in your Bitbucket, and whatever it is that you use as a code repository, that's when you want to, jump in and do all those validations automatically, right? So that's the first step. The second step is more dynamic analysis, right? And among all of these things, I see a lot of people doing container analysis. That's kind of getting really in the mainstream now. So all the tools that allow you to actually do that, embed some container images analysis in their deployment scripts are also very important, not to leak those secrets, to see what they're doing, hard-coded stuff. So you have tools that allow you to do that as well. But one of the key points that people tend to forget in here is what I've highlighted here in blue, which is to hack yourselves, right? If you want to do security, you really have to think like the bad guys. You have to think like, okay, of course, the developers, they're going to test the functional behavior of the API. What should happen if everything goes well? Is it conforming to the functional requirements, basically? But from a security point of view, how are the hackers, trying to defeat your APIs and see what they can do? They're going to start bombarding it with all kind of information that you don't expect. Put some scripts in headers and inject this huge number in the place where you're expecting 1, 2, 3, or inject images where you're expecting strings, so that's what it's going to do. It's going to just inject all this bad data and throw all of that at you and see how your API is actually reacting. Is it leaking some extra data? Is it leaking some exceptions? So it's one way for them to know, okay, oh, I found this now. I can pull from that thread and do another test that will give me more information. And that's the way hacking is working. That's just no magic, right? It's just go and discover information by testing and see how, what information they can get through the APIs. So this, what I call negative testing, right, is really key at that stage. You really want to bombard your API with all kind of bad stuff to see how it reacts, right? So that's kind of thing that we do, for example, in our conformance scans. So based on the contract, we'll just go and call your API and send it, all kind of bad verbs and bad content types and out of bound data, and sending you a string when you expect a Boolean, and sending you an array when you expect a string, and see how the API is actually reacting. And in every single POC that I'm doing, in every single one of them, we find some problems because either the code or the framework underneath the code is not handling those cases properly, right? So it's a very critical step. When you pass that step, ideally what you should have is you have a strong code that is, very locked down, I would say. You have locked down images. You don't have any libraries that you're using that have some vulnerabilities. Your deployment scripts are clean. So you're at a really good stage to go to the next level, which is then go in production. And this is where, you now have to test where you're going to host your APIs. That's also part of all that journey, which is, okay, I'm going to expose my APIs, which are super locked down, and I'm putting it onto a Kubernetes environment that is not secure at all. Well, that won't work, right? The same way the other way around doesn't work either. I can have a super locked down Kubernetes environment. If I put some APIs on top of it, which have tons of vulnerabilities, well, that's not going to help. That is not going to work. So if I have if I have locked down my APIs, I want to make sure I do the same thing for the environment in which the APIs are going to run. That means we have to validate how it's set up from a TLS point of view, for example. We have to look at our component configuration and test that. We have to do some perf testing of our API. Why? Because we want to protect ourselves from type of DOS attacks. Like, what is the limit that the system can handle? This is a, I'm opening a quick parenthesis here. We have a lot of people asking us, so what is the performance that your API firewall can handle? And I say, what is the performance your backend API can handle? That's what you need to know. I can do 10,000 TPS. Can your API do that? That's the problem. You need to know what are the limits, because you need to close the door at the front. You don't want to close the door at the back. It's very important to protect yourselves. You want to, if your API cannot do more than 500 TPS, then your protection at the entrance is 500 or 400. It's just to make sure you don't go over that limit, right? That's very critical. So you need to know that information. And of course, we'll do some pen testing there, but that's more like a manual process. So this is all the stuff that we have to put in place, right? So the tools you're going to put in place, the rule of thumb of this really is they need to fit in the developer flow, right? So you don't want to put in the hands of the developers, you don't want to put in their hands the actual tools that you were using for security before, right? You need to, basically what the developer wants is they're in their IDE, they're in the CI/CD, they just do their work as they were doing, but there are those things that happen behind the scenes or tools which are integrated that help them being better security. That's what we want to put in place, right? So we want tools that fit in that flow, that are integrated in the IDEs, that are integrated in my CE pipeline, or it can be API driven, so we can automate all of that, and that integrate in the ecosystem. So if I have my logging, my monitoring, I can plug those tools in each of those environments, my Elasticsearch, my Splunk, my Azure Sentinel, whatever it is that I'm using, to be able to see what is happening and all the problems that those automated tools are discovering, and push them in a place where it's easy for developers to see what are the problems and what they have to remediate, right? And I didn't put this in that slide, but that's another important thing, which is to also fit in like the issues, the GitHub issues, the Jira, whatever you're using for everyday issue management and problem management. Okay, so another time to just take a pause here for a second and do a quick demo. As part of this webinar, one of the things we wanted to talk to you about also is our brand new integration into Bitbucket with pipelines. So I'm just going to show you that for a few minutes. And I will start from Visual Studio Code, okay? So I have this project in Visual Studio Code called Webinar Demos, in which I have a number of APIs, some 5G stuff I'm working on, and Beyond, some sample files from things from Veracode. We were testing. So anyway, so a few different APIs, and I have this Bitbucket pipeline that has been created. Very simple. All we have is a pipe in that pipeline, so a new step in that pipeline if you want, if you're not using Bitbucket. And then what this is going to do is audit the contract. So this is part of more like the dev aspect of our entire pipeline, where we're going to take an open API file, we're going to analyze it and give you an audit on the problems it may have. So we can run this from our IDE, as I was saying, so we can run this in here and we'll have a score that will tell us, hey, you have a score of 53, not too bad. You're doing okay on security, or missing quite a few things on data. This is all about how did you describe the data? How did you describe the responses? For example, something like this, right? But I have a schema that describes some information. Well, this only tells me the schema contains a string. A string can be a lot of things, and it can contain a lot of information. So when we validate against that schema, can you give me a bit more information so we know that actually the length is okay and the pattern is okay as well? So we need those two things. How big is this? And can you tell me a bit more about the format of it, right? So if I do a validation of that 202 response against its schema, I can actually validate that the response that comes back does correspond to what we're expecting, and we're not leaking information in that message. Like recently I had a customer, for example, was asking me, can we filter all strings to understand if a JWT is being leaked out? So if somebody injects a JWT inside an error message, how can we block that, right? Well, that's the way to block it. It's just to really describe what it is that you're expecting in there, which is just not simply a string. So that's the tool run from inside the VS Code from my IDE. Now, from an automation perspective, what I'm going to do is I'm going to say, okay, there's a bunch of files in that repository. Remember our key problem, originally we talked about discovery. It's like how many APIs do I have? How many swaggers do I have within my repos? And if there is a swagger, there's probably an API behind. So let's go and crawl all of these and discover those files, right? So that's what this conf here file is actually saying on top of my Bitbucket pipeline. And just for the sake of it, I'm just going to say, well, I want to block all files that have errors with medium, high, or critical severity, okay? So I'm just going to take that and I'm going to push that file. Let's call this demo step 1. Okay, and just save that and push it. Okay, and here we have our Bitbucket. All right, so we should see this build coming in a few seconds. We have a new build being started. Here it goes, demo step 1. And what this is going to do, it will invoke the same audit, so the same exact functionality I just showed you in VS Code, but it's going to also invoke it now on CI/CD. So what this is going to do behind the scenes, right, is, or what this is actually giving you is this governance aspect. So yes, we have developers that are just every day looking at the code, doing this VS Code, testing and everything. But how do we enforce that? We have to enforce it in a central point. Well, that's what the CI/CD gives you. It gives you that point of control where I'm doing the same validation that the developers are doing, but I'm going to do it inside my pipeline. So that takes a few seconds because it's discovering all the files, and then it will report on the different files that I have in there. Here we are. So it has found them. Okay, and this is what it has found, right? It has found, we have multiple files in there. Let's make this idea. Okay, no. It has audited 49, 92, 5, 25. So we said that the limit for the highest, the score actually in this case is 85, right? So anything below 85 is going to be blocked. But on top of that, we also have per file the number of issues over medium or higher, right? So this is kind of a discovery platform. So if we go to our platform now and I go to that webinar discovery, we will see that we have imported all those files. There's buy-in files that we had, sample OAS, pet store, open weather, etc., etc. And we see that score we saw in VS Code, the exact same one, except we see it now in a different way within our SaaS platform, right? So somebody can go in there and see what the details are, even if they don't have the IDE plugin. Okay, so that's the first step, which is kind of discovering, right? How many do I have? And now I have them all reported here. I have this dashboard, which allows me to see how many are valid or invalid, you know, the type of scores that I have any with a green score, the kind of orange and red. And the number of issues as well, which this buy-in has a lot of issues, like about 2,500, financial market as well. The others are, you know, smaller in terms of the number of issues. So I've discovered those. Now I can go and investigate, right? And the other way of working with this is actually to go and analyze a specific file. So I have this like pre-configured here. I'll just put that in there. Okay, and say it again. So in this case, we don't want to do discovery. We already know our API. This is the ID of the API in our platform. And this is the file. So what this is going to do is every time it finds this file, it knows it has to go and update the existing API in our platform and create a new audit report for it. And here we're saying we're going to block on anything which is critical or high. So let's go and push that now. Very interestingly, this demo step 2, so we know where we are, and push that. Okay, so back to our pipeline. We should see a new build. I'll take a second to actually run there. So what will happen now is it will go and start the build. It will analyze this single file and upload it to our platform. It should do that in a second. While it's building, maybe it's going to take a bit of time before they give me a machine there on that system. So let me show you another one. Okay, show you what it will do. So what it will do is this, right? So it will now look at this one file and upload it, right? Instead of going and discovering it. And if I click here, I'll see the report for that one single file, which is 94. That's the one we just uploaded. And few issues which are actually remaining, right? So that's how we would integrate that audit in the pipeline. So back into our presentation. So we've done the audit, we've installed the tools. Now, how do we defend? So the idea of the previous step is really to put all the rules in place and making sure like everything's fine. Now, how do we enforce that? So I've put some runtime rules. I want OAuth with authorization code with Pixie, right? How do I enforce that? How do I enforce I have all this stuff put in place? So again, there's two things you really have to do here and care for here. The first thing, and pretty much every single customer I talk to wants to do this, you really want to also automate entirely the deployment of the protection, right? And you want protection in multiple places. Most likely, if you're a microservices shop, so you're doing development and using microservices, and you have put in place something like a service mesh, for example, remember, a service mesh has some automated policies in there. They're all linked to the infrastructure, which is great. So make sure that, for example, the APIs can only talk through TLS or mutual TLS even, that you are validating the communication and authorization between those different services within the mesh. That's all cool. On top of that, think about the validation of the data and the access tokens and everything, because that is not done by your service mesh. The service mesh only deals with infrastructure, right? So you probably want to put like a firewall in there, something that will do all this validation for you automatically. And you probably want to do that as well in front of your gateways, of your existing gateways. The same way you would deploy a web application firewall in front of your apps. You need some new type of technology to protect your APIs. That's why also we're doing an API firewall. And because that's the technology that will allow you to really protect specific API traffic, right? So what is also very critical is this enforcement has to be deployed automatically. So ideally what you want is you push your code in Bitbucket, as we've seen now, that triggers that pipeline that audits the code, automatically tests it, automatically creates the configuration for your runtime and your API, automatically creates the configuration for the firewall itself and deploys all of that in one click, right? That's what you want. You want that repeating loop that doesn't have any manual intervention into it. So, select tools based on those functionalities and put that in place early. So I see a lot of people saying, well, we'll put that in place when we deploy Canary, right? When we do like blue-green deployment, We just put the protection in that blue-green deployment and in production, but not before. This is, you shouldn't really do that. You should really do it providing that the pricing structure of the things that you will buy allow it, which can be an interesting factor. You want to do this really in development. You should really have always security on. That's the key thing, so that you're not surprised by all those security issues when you get to the canary deployment and the production deployment. You want to know about this way earlier. Otherwise, it's going to block your deployments. It's going to be a problem, right? So that's key points: making automatic, deploy early, and again, protect all your APIs, not just the ones that are going to be consumed externally. Yes, those ones are important, and they are more risky. So you prioritize those. That's fine, but don't neglect the internal ones, right? And don't neglect this protection of in the east-west communication, so the inter-services communication. Those are all vulnerable as well as the external ones. Okay, and finally, monitor. So this is really about knowing what is going on. One of the key aspects, again, I'm repeating myself here, but it's very critical of DevSecOps and DevOps, is this feedback loop, right? Is like, you want to know about a problem as early as possible so you can act on it. And you want information which is, to the time, very precise. So you have, minimal false positives, so you can focus as a developer on those problems, knowing they're real, right? And fix them. So that's really what you want. You don't want to have this like 10,000 problems being thrown at you when you're ready to deploy the API. You want to know earlier. So that feedback loop is really critical at dev and QA time. And in production, well, for many reasons, you really want to log everything and know about what's going on. Of course, for monitoring purposes and understanding what's going on, but also for forensics later, for the feedback loop at a runtime level, for analyzing those logs and understanding behavioral changes. And of course, to be able to alert on different patterns and things which are happening in an automatic way, right? So again, when something is happening, somebody is trying to, hack your API with different calls than it should be, with bad data, you should really be alerted. You have to be sure you can know about this. So even if something happens, you're not going to let them do this for a week or for 2 weeks or for a month. You're going to let them do this for 5 minutes, maybe, right? Until you actually realize that there is a problem. So automation in that case is extremely important. Okay, so that's kind of in a summary, right? So don't panic if you haven't done any of this, right? It is a process. It's not a one-time shot thing. It is, again, a change of culture and different way of working. So it's going to take time to adopt all of this and get to a certain level of maturity. So start small and then iterate. Don't try to resolve all those problems in one. Pick up your most valued APIs, the ones that would make you appear in the news if something happened to you. Or would trigger some, really bad reaction from your customers, even if it's not public. Pick those and start working with those, right? And do all that process on those and define those rules and what they do, etc. for all of those. And then please invest in helping developers understand better all of this. So bring security people into development teams if you can do that. There's a lot of security people that need to learn from development as well. It's a two-way exchange. Traditionally, security people have been quite far away from what's going on in that code. For example, in OAuth and all those security things which are very specific to APIs, they're not so well known by the security group. So you putting them together is actually a very good thing to do, and everybody usually benefits from that, right? And then don't throw security as a new responsibility to developers. It's really it's just a shared responsibility that we want to get to. And finally, don't get all the tools I had in that slide and put them in your pipeline in one shot. One thing that we learned also from many customers is if you're going to throw multiple things in the pipeline and then suddenly whenever I push some code, it takes 5 minutes, 10 minutes, or 15 minutes to get it to build, that is not going to fly. That is not going to work the developers, right? So be careful about what you add to the pipeline. Put things which are like not too disruptive, I would say. Otherwise, put them in a different pipeline, but not in the development pipeline, right? And so evaluate the things that you need and go and adopt those, you know, step by step. And that's what I had for today. Thank you very much. Do you have any questions, Christine?
Thanks, Isabel. Hi, guys. I'm back. We have a question here. Don't the cloud service providers offer API discovery and inventory services?
Some do, yes. But it's not a simple problem. So you have a discovery at design time, right? So there's two types of discovery and understanding what goes on in your system, right? There's discovery at design time, like the one I've shown you. Go and look around and see if I can discover the APIs which are running in my system. I've been created in my enterprise. And then there's a runtime discovery, right? Where you could, you know, for example, look at traffic and try to guess, oh, you know, there's a lot of calls going to those places. Is this an API? If yes, oh, I may have some shadow APIs in there that I didn't know about. So you kind of need to look at both. And there's a lot of different solutions around that at different stages of the API lifecycle, I would say. And yes, some cloud providers actually have some solutions around that.
All right, that is the only question. Oh, no, got another one. Got more. Probably been in here now.
I'm thinking about it.
I was about to just wrap everything up. Is there any possibility of fixing these issues once found in runtime? Can all those issues be fixed?
Every issue can be fixed. It's a bug. Any bug can be fixed. You know, yes. It's just a question of time. So what you want to do is just to discover those issues as early as possible, so that time it takes to fix them is actually optimum. That's the key point, right? Is if you have the time and development to fix those things and learn about them and don't commit them in the first place, that's where we want to yeah. But then there are just bugs. Yeah, sure, they can all be fixed, no problem at all. Whatever you find as a solution.
Okay, next question. Is it true Bitbucket now has security integrated?
I'm not sure what that means. It's a very big context questions. If you want to refine that, it has the ability to put some secret variables, that I know, but I'm not sure what security integrated means.
Okay. And then I hope I get this one right. How can you do a security audit for a private or hidden API via black box?
Okay. So the audit, if you're talking about our audit, we only need, we don't need the API implementation. We just need its contract. So we need a Swagger file, right? So we don't need to access the implementation, even if it's an air-gapped environment or a black box of that kind. We can't do. We don't care, right? This is static analysis. In terms of the scan, which will be like more the testing aspect of it, what we just need is an endpoint to talk to, right? So ideally, probably that scan engine that invokes the API and discovers all the problem needs to sit in the same, I don't know how you do that black box, but in an environment where it actually has the ability to talk to that API. Now, watch out, you want to do this at QA and dev time, right? You're not going to do a scan at production time. So I don't know if you have the same black box concept and air-gapped concept in QA than in dev, and in dev than in production. But that's where it would happen, right? It would really happen production, not in production.
All right, thanks, Isabel. We're coming up here on the hour. We'll take one more question. How do you do API security testing on rate limit part of Cloud API?
Oh, you do that with something like Gatling, for example. I'm just saying that because it's open source. So you need something that generates a lot of load and see how your API, rejects that load.
All right, thanks. All right, guys, we're going to wrap things up. If there are any questions we didn't get to or thoroughly answer, we'll look at them after the webinar and make sure that we answer them in the blog. And I will send you all a link to all the follow-up materials as soon as they're available. Thank you so much for joining us today.
Thank you, everyone, and have a great rest of the day.